everyone. Quite a big turnout. You're going to have to forgive me for my voice. It's just a bit rough from last night. So, apologies. So, today I was planning on talking to you about microservices because obviously you haven't heard enough about it these past few days. So, I'm planning on fixing that. But so, before I started, I wanted to give you a bit of context, give you a bit of history about myself and why I chose to talk about this particular topic. So, I'm Sam. Thanks for coming to my talk. The inspiration for this talk really is because I'm a conference junkie. I go to a lot of conferences, and whether you go to, talk about domain-driven design or TDD, test-driven development, continuous delivery, or a new paradigm of learning, you sort of, you come out thinking, oh, this is really interesting, but no one really talks about their failures, right? And it's quite strange because we are in a very unique industry where we learn from our failures. Like, no other industry has that. You don't have a doctor that keeps killing people, going forward really far, or a pilot that keeps crashing on takeoff going really far. But with us, fail fast was a motto in our industry for a very long time. So, that's what's the inspiration for this talk was, like, we went through quite a rigorous, painful journey of going and breaking down a monolith and decomposing it. And if you think this talk is going to come and tell you, microservices are the future, go for it, they're amazing, you're kind of going to get disappointed, because I'm just going to tell you about how we failed in certain situations and how we struggled and what we learned from that. And it was really enjoyable. Well, not enjoyable, but it was really entertaining, for lack of a better word. So we're going to talk about a lot of interesting stuff. So we're going to talk about events, commands, CQRS, domain-driven design, messages, distributed systems. Sam, Elamin, I'm up there. I'm interesting to talk about, so it's going to be quite a few. And if there's a buzzword here that's missing, please come find me after the talk. I'll add it. So the first sort of question that you ask yourself is why? Why do people build monoliths? I mean, we know it's difficult to work with. We know it's difficult to maintain. Why do we put ourselves in this sort of situation? Why? And really, the simple answer is because when you first start off with an idea, you don't know if it's going to make money. You don't know if there's any value to it. So you sort of like, I'm just going to knock up something really quick to see if people will use it, to see if people are interested in it. And, scale isn't really a problem at the time because you have nobody using it. And that's kind of the reason why languages like PHP got so popular in the past 10 years. It's really easy to just knock something up and go and get it out there. And once you start seeing people use it, you're like, okay, we're just going to add little more features here and there. And it grows and grows and grows until it becomes quite unmanageable. And that's the reason I think you have situations where you build something that's so massive that it's so difficult to work with. And the more people you add to it, the worse it gets, I guess. So that's sort of the situation we found ourselves in. We had a massive .NET application. We had one monolithic database behind it. And it was very difficult to reason with. It was very difficult to work with, to make changes. We had annoying frustrations where, we'd work on one thing to try and fix a feature, 3 or 4 or 5 other things break when you end up deploying it, and it's just so painful. And I'm sure so many of you, because every time I talk about anything relating to that, so many people tell me, yeah, we have the same problem. So it was really painful. We had very massive long deployments where we'd be on Skype calls, and there's certain members of the audience who were originally in one of those Skype calls where we'd talk for like at least an hour or two, telling about how these are the tickets we're going to be deploying, this is what we have to do, and you get bored. You're like, I'm actually going to check Facebook or Twitter to see what people are doing this weekend, because you're just talking for so long. And it was just so painful. We were like, okay, we know we got to change. Actually, working with the code, when we make changes, it just felt like this. It was just constantly fighting with it. It's just making any sort of change felt like the code was like, nope, you can't do that. Nope, can't do that either. And it was so painful. So we sort of said, all right, guys, we're very smart developers here. Come on, we can make some sort of change, right? We know this is not reasonable to work with. Let's change it, and collectively we can come up with a better architecture. And we sort of went to the business and said, we need to do something about this because it's really painful. And they were like, actually, no, you don't, because it's making money. What are you on about? Re-architecture always just says, you're making something new with no business value. So you're developers, you don't know what you're talking about. And most of the times, business domain experts have been with the company much longer than developers, so they see a lot more turnaround. Like, I don't know how it is around Europe, but in London, the average turnaround is about 2 or 3 years before people move. But with domain experts, they tend to stay there for 10, 15 years. So they see these rolling doors, revolving doors to what feels to them like revolving doors of developers coming in and they're saying, actually, this is not how it's supposed to work. And they're like, well, it's been working like that for the past 10 years. It's profitable. You don't know what you're talking about. So I guess that's one of our first mistakes. We didn't communicate clearly why we need to do this and why we will struggle in future if we didn't. So we're like, okay, well, they don't know what they're on about. We'll just refactor it, right? We're just going to be, it's basically hiding things. It was very underhanded. We were like, okay, fine. If they're not going to tell us the next user story where we have to work on this part of the domain or this part of the application or this part of the bounded context, what we're going to do is we're going to remove it. We're going to start trying to move it away. And they don't know what they're on. We're just going to add 2, 3, 4, 5 days extra onto the time estimate to sort of break it apart. Since they're not going to trust us, we know better. And that was, again, one of our other failures, was we're like, okay, if they're not going to trust us and we failed at communicating, but we didn't admit that, we're going to just say we know better, and we're just going to add more time to our original estimate to try and refactor it out. So this is our underlying goal, right? This was our underlying goal. We have such a massive application, and if we make it smaller, will be much easier to reason about, much easier to deploy, smaller changes. We'll be able to deploy, we had 2 or 3 weeks release windows, and we'll be said, well, maybe we can deploy in 2 days. Imagine how awesome that would be. And they were like, okay, if it's smaller, it must be easier to change, it must be easier to fix. It would make our life much easier. And that was always the goal, right? That was always what we wanted to do. So we had domain-driven design as our Bible, and if you haven't read this book, it's really, I would not say interesting, but it's very important if you're going to break anything down. It helps you identify what your boundaries are, helps you identify what your context is, and it is quite an important book. And it's all about where the boundaries of the business are. We said we're going to use PubSub, right? We're going to PubSub everything. And for those of you who don't know what PubSub is, it's just a way of communicating between messages where you've got a publisher that is, let's say the website says, okay, I'm going to talk to this component and tell it this person's made an order. So this says, okay, order placed, and then there are certain components, which are the subscribers, that says, okay, I heard order placed, I'm responsible to go and take payment. So this says, okay, go make payment. So then when this says, okay, I've made payment, it becomes a publisher and says payment complete. So then there's subscribers that says, okay, now that I've heard payment, I can decide on, okay, I'm going to go assign stock to it, or whatever business logic or your flow is. Once it hears this, then it does that. It's a very, in theory, worked really well. And we said, well, that works our business model, so we're going to follow this thing. So we started off by saying, right, okay, once we know what we want to do, we know what we want to achieve, what we're going to do is try and identify a bounded context. And for those of you who don't know what a bounded context is, it's like a boundary. It's a boundary of where you want your code to live. So for example, a boundary of payments, that's very simple, it's very contained. And you've got a boundary of the customer services. If you walk through your business, actually physically walk, you will see the business split into these partitions of what they do. So we were like, okay, look at our code and how does it actually map to the business? And we're like, okay, this part starts talking to customers. Okay, this seems like it's customer services oriented. This part does payments. This part does the ordering. So we know what the bounded contexts are, and we know what splits that we need to take out. Once we split once we started taking things out, we quickly realized, hang on, we have the sessions everywhere. Everyone's editing the table. and we have some sort of separation, but then this thing here who has no responsibilities for this particular table is making changes to it. You know, it shouldn't, because we've got this tightly coupled with the database. So what we said is, okay, what we're going to do now is every new table that we're going to work with, or every existing table that we have, what we're going to do is define an interface. And any change you want to make to that particular table goes through this interface. That basically enabled us to abstract away the database. It quickly, within a month or two, we were able to start working with different types of databases. You know, we went to NoSQL, we tried Mongo for a day, and then we moved away. We worked with Dynamo, and it basically enabled us to work with any sort of database technology that we wanted if we're able to talk with these interfaces. And Peter Hinton said a really good point on his talk earlier these past few days, where he said contracts, and it's that important. The interface is the contract. I want to make change to this. I don't care where you keep this data. My intention is to make a change to this particular thing. And that basically said, okay, now we can move away. We can use text files even for our database if we wanted. And this interface was very important. So that was a very useful technique. So those were the steps that we decided we started doing. But what we found out was we wanted to go distributed, and we had no idea that things can arrive out of order. This race hazard or a race condition was something that we never really experienced. We never really had that particular problem. With a great failure of mine, I remember, was we had a very simple requirement come in, and we're like, okay, we have a customer, and they're assigned stock, but if they haven't paid for this thing within a week, we assign them the stock. So what we're going to do is send them an email. We're going to send them an email to say, listen, you haven't actually paid for this thing, so if you don't pay with it within X amount of days, we're going to free up the stock for other customers. So the thing was really simple. It just listens to order placed and just waits for payment captured, right? And if it doesn't, it's going to send the email. That's literally all the logic that was in that particular service. What we quickly found out is things arrive out of order. So you would hear payment captured, then you would hear order placed, but you never hear payment captured again, because you already heard it. And then the application is like, okay, I heard order placed, didn't hear payment capture. What I'm going to do is just send emails. So we got customers calling in. It's like, what are you on about? I've got my PayPal receipt right here. It's confirmation. What is wrong with your developers? Shoot them, kill them, they're useless. And they were extremely frustrated. And it's completely understandable, right? You've got the confirmation email, and you get another email from the company saying, actually, you haven't paid for it, so we're going to give stock away. And it's just incompetence. And they get really angry. So we got so many of these problems, and we'd not see them in QA. And the reason is we don't have that normal load. We don't have that such a load going through our QA environment. So we weren't able to replicate these issues. So every time we'd get domain experts or the client services admins or something calling us saying, okay, there's a problem with the system again. Can you tell us what it is? And we're like, oh, it's a race condition. Oh, it's because they came out of order. So to the point where they were so frustrated, where they were like, yeah, say it again. You were so frustrating. Before you guys joined our company, everything was fine. Like, we had a few issues, but now you're creating issues as you come along. And I can understand that, because it was a very painful teething period, basically, of us. We're learning as we go along, and we're trying to see these problems. And it's the problem with being in a distributed system. It's the nature of the beast, basically. Things can arrive out of order, and you have to put it into your code to sort of deal with this thing. And what we did was we're like, okay, we're hearing payment captured, but we actually didn't hear anything about order placed, but we have the order ID in the payment captured part, so it must have happened. So our logic in the code was able to sort of be smart enough to know, okay, this thing must have happened. I'm not going to go and send emails, right? So, so that's what we quickly found out. So the next thing we found out was actually testing is actually quite hard. Testing situations that have arise in production is actually much more difficult to do in a distributed system than it is in a monolithic application, basically. We started getting problems that would not have been found out using unit testing. For example, something comes up and it can't subscribe to that component it was supposed to. So it would be like, okay, I'm not going to do what I'm supposed to do because I didn't hear a message. And a unit test wouldn't have helped you do that. It's a problem with the underlying infrastructure. Situations like that would happen all over the place, and we quickly had to sort of deal with it, and I'll show you the different techniques that we did to sort of deal with this situation. But we quickly found out testing is actually very, very difficult. Not only that, but deployments. Now that the good thing about having this bounded context is teams who own the context had autonomy. So every team had freedom to choose whatever they wanted to do. So every team was like, actually, we want to deploy with a certain way. We want to deploy using Ruby. We want to deploy using Rake. We want to deploy using MS Build. We want to deploy using PowerShell. And each set of services would be deployed differently. And if you're working cross boundaries, you're like, I don't know how to deploy this stuff. Right? And it was, we quickly had to agree on a consistent way of deploying. Because if we're working cross boundaries, we need to work with those features. Even though we don't own them, our feature touches them, so we make changes to them. And it was very difficult to agree on the best way, but we sort of said, okay, the majority is using this, let's just use this. And that's what we went to, and we sort of deployed them to one set of environment, because you can't deploy 50 or 60 services on your machine, no matter how powerful your machine is. Running everything in one local machine is difficult. If you're working on a distributed system, you quickly find out that you need to learn how to mock stuff out and assume that this is what things happen when they come in, and then you work your logic and then you push things out. You can't have your entire system in one machine. Then we had the problem of, actually, who owns this particular thing? Now, when you've got such a massive monolithic legacy system, you realize that there are maybe 2 or 3 people in the company that have a vague idea of what everything works, how everything works, but then everyone else is sort of somewhere in the middle. They don't know how everything works, they don't know how their feature works. So they're like, actually, there's a problem. And because there were so many problems happening in production, they're like, actually, I don't know who owns this. I don't know who owns this. And there was, again, a lot of fear of, actually, I don't want to change this because I don't know who owns this. Oh, that's the problem with fulfillment, but it was due to the messages from payments, and it was unclear. There wasn't. And that, again, came back to the fact that, we wanted to apply domain-driven design without involving the business fully first. And that was that was definitely a failure. But we needed to understand what the boundaries are. We need to actually get the business involved to sort of say, okay, where are your boundaries? So that it reflects into the tech. So that sort of caused that. And when you have a lot of problems happening in production, people become very gated. They're like, whoa, why are you making any changes, right? I want to know exactly what you're doing, because there seems to be a lot of issues happening in production, and they get very protective. And I remember we sort of said, these people are making changes to our stuff, but we're getting quite strict, and the things we're strict about aren't about knowledge sharing. We're just being strict to be assholes. Oh, actually, no, you're using tabs. This is spaces. Even though I know that the other parts of the solution have tabs, or the other parts of the solution has spaces, but this is new, so I want it in tabs, or I want it in spaces. It gets really frustrating, and you don't end up people become quite frustrated. They don't want to make change, and even though it's not an open source community within a company, it is kind of like that, because everyone's free to use your components, and everyone's free to make existing changes to your components. So what we did was we did something quite disturbing in my team. What we did was we said, okay, guys, as long as whatever code you're going to change to us, as long as it's covered by a test, right, we're going to check in. If the test passes, we're just going to merge it. We want you to know we're merging everything. And that sort of brought them, was like, okay, that means I have to be sure that my changes are working. And it added more tests around the stuff they're passing into us, because we basically gave the onus to the people making the change. It's like, listen, we're going to merge it in. So it sort of moved away that particular blocker, and people are like, okay, I have to fully understand the change I'm making, and we basically said we're going to have to trust them. That really worked. We ended up having much more test coverage on our application, because we'd be touching other people's stuff, and people making changes to us would just be adding more tests around our stuff. It was brilliant. So Then we're like, actually, we have at least 50 or 60 services now. We need monitoring around them. We need to be aware if they're working. We need to be aware if they're healthy. And that's the concept of the health check. That's what occurred to us. Like, if an application comes up or a component comes up and it's supposed to subscribe to 3 or 4 endpoints and it can only subscribe to 3, it should say, okay, I'm unhealthy. So the way we had monitoring around is like, okay, this thing's unhealthy, so what we're going to do is we're going to kill it, or we're not going to add it to the load balancer. And there's certain techniques they can use to sort of say, okay, when this thing is healthy and it can talk to what it's supposed to talk to, it can deal with its dependencies, that's when you put it in service and you put that into your deployment. But monitoring became very, very important when you start working with distributed systems. It's actually very important to know that everything it's supposed to talk to is able to talk to it. But we quickly, well, not quickly, but we finally understood what our original goal was to reduce complexity. But Michael Feathers has a brilliant blog post on this, is when you're reducing complexity within the code and you're making it into microservices, you're invariably pushing the complexity between the interactions of these components. You're not destroying it. You're just making it seem like it's between them, and it's hidden. You don't know it. And we had that. We had that with people coming in, and they're like, okay, I know that I'm in charge of this context, and I know exactly what happens with this. But how does it fit in the overall flow? How does the point where the customer says checkout to the point where, we ship them their stuff, how does it actually connect together? And because we had a distributed system where, we were like, okay, we can tell by the messages, but it's actually quite obscure for someone new. It wasn't a very easy, simple flow to understand. So the question we sort of asked ourselves, the retrospective that once we had, when we went through the majority of that journey, is, what we should have done. What could we have done differently? What were our learnings, our major learnings during this experience? And the first thing is get the business involved. Explain to them, right? Explain to them that this is not going to work. And you're going to have quite frustrating meetings. Like, you're going to have situations where I was like, this person here, literally, you're not listening to me. This is not going to work. And I think something that really works for us really well now that we've done it is we would have vision meetings, right? And as hippie as it sounds, the business normally goes through meetings about where they see themselves in 3 months. This is how much profit we're going to make. This is how many sales we think we're going to make. We're going through these campaigns. But when's the last time tech said, okay, we know that the campaigns are going to run. We know there's some sort of campaigns. We know that the business wants X amount of orders in 3 months. Can our platform support it? Where are we? I mean, the business isn't going to use a different platform to deal with these forecasts that they put in. So your application needs to be able to support it. So that's a brilliant way of saying, okay, this is why we need to do it. Because you think we're doing 20% more orders. We can't handle that now. So that is a good, very strong argument. If you're going to say we won't be making 20% of orders instead of we got to re-architecture because it's a pain to deploy, that's not going to work. Like, I remember the conversation I had when we were like, actually, we need to change this. They said, why do you need to change it? I said, well, it's really painful to deploy. They're like, well, it's fine. We deploy for 2 weeks. I said, well, we could deploy even more things. And they're like, what? We're not pushing you hard enough, obviously, because we're extremely happy with the output you guys are doing. And if you're saying that you could do more, that means we're not working you hard enough. So the next sort of question that sort of answer, obviously developers don't agree, right? And they're like, actually, is data duplication bad, right? Because everything we communicated via messages, there's a lot of duplication in data. Things like the user, the order ID, what they ordered, the lines, there's a lot of duplication there, and you're like, is that a good thing? We have this one particular data store for this set of components, or the read model for this set of components, and we've got a read model for this set of components, but there's a lot of duplication. Is that a good thing? Is that a bad thing? And I said, I prefer data duplication and decoupling over the fact that we had that tightly coupled, and because of the pain I felt with having the single database. And I feel like the exact nature of the domain will change, right? the language that you're using, for example, to give you a more concrete example, if you look at the concept of an order, right? An order to finance would be like, okay, what does this person order? And it could be 6 or 7 things, but how much are we charging them? They could be getting get two and get one free and so on. How much are we charging them? But an order to the warehouse is like, what things do we have to put in this particular box? So the meaning of the term order would change differently in the business. So to me, there might be data duplication to start off with, but the meaning of the data will change over time, gradually. So I'm happy with data duplication. And there'll be situations where you might not agree, but it's all just the nature of the beast, I guess. So the next thing is, would an orchestration layer have helped us? And basically some sort of layer that says, like a routing layer that says, okay, I've heard this message, I know that the next message is supposed to go to these set of services. For example, order place, I know now the next step in the business flow is to take payment. So it goes into the orchestration layer of the payments, and it says, okay, take payment, and then that talks to its set of services, the PayPal service, the JPMC service, the MasterCard, if you've got a set of payment providers that doesn't do MasterCard, for example. And to deal with taking that payment, then it comes back and it says, okay, payment's been successful. Okay, what's next in the flow? Assign stock. Okay, what's next in the flow? Send it to the warehouse. Okay, what's next in the flow? Ship it to the customer. And that we could have easily taken to a new starter, someone who is unsure of the other side of the components. We're like, this is the flow of the system. And the thing should be really stupid, just routing messages. But would it have helped us or not? I'm not quite sure. But we would have been easily able to help people understand the flow of where the data goes. We also quickly found out that we need monitoring greater than acceptance tests. We had situations where like, actually that should be okay, because look, the acceptance test we ran once before deploying was green, so obviously it's working in production now. We had to have a concept of an alert, and if you think about an alert, it's really just a test running in production, right? Can a user log in? An alert would be like, actually a user can't log in, alert the people, and we're fully DevOps. We own the code. We don't have an operations team. We don't have people we throw the code over and sort of say, okay, you deploy it, we're done. If there's a problem in production, we own it. So we're incentivized to continuously add alerts around the stuff we deploy, things like metrics, and that basically became really, really powerful. Right? We started getting dashboards, growing dashboards of, and I'll show you, if there's some time, I'll show you some of these dashboards where we're like, okay, every time something happens, every time an intent is made by the user, we log it, we stat it, sorry. We're like, okay, there's been this amount of requests made to check out, there's been this amount of requests made to attempt payment, there's been this amount of orders been placed, and basically, that basically says if there's a failure, you'll be like, okay, there's been 100 attempts, but 0 successes. There's a problem there. That gives us immediate feedback to when you deploy something, there's definitely a problem. There's definitely a problem because things are going down. And we expose these dashboards to the business as well. And it gives them from 0 confidence in us to like, the power of, they come to us and say, oh, there's a problem. We're like, we're aware of the problem. And this dashboard we linked to a week ago will show you that this is how we found out. And it gives them insight into exactly how their platform's working. It's exactly what is a customer's doing right now, right this second, how many orders are being made, how many payments are being attempted, and so on and so forth. And it's very powerful and gives them immense confidence. So the metrics basically gave us quite a lot of freedom. We're like, we know we can make experiments, we can deploy something, and we immediately see if it increases conversion. Are more people hitting the sites? Are more people making orders? And if there isn't, the ability to quickly roll back or quickly roll forward is there. And it gives them it gives a lot of freedom. And it's a double-edged sword, right? It's the same with the deployment. It's a double-edged sword because, there's teams now that are like, actually, I want to learn Golang, or this other person wants to do Erlang. And even though the service is quite small, as long as it communicates via HTTP or is able to talk via messages, we're fine with it. But you have to have an agreement within the team because you're still able to rewrite it. You're able to rewrite the service, but it must be painful if you've got someone who's like, I don't like F#. Why do I have to keep rewriting every time you write a service into another language? So it could be balanced, so you have to agree within the team. So as you can tell, when you work in a distributed system, you'll end up having these 2 pizza man teams or whatever the size of them. But it's normally between 4 to 6 people, and you're going to work a lot more collaboratively than when you're working on a monolith, I find. So you have to come up to some sort of agreement to how you're going to work. So basically what the future holds is, I think with the fact that Docker's coming, we launch everything in the cloud. We launch everything in an EC2 instance, which is a virtual image, just Amazon's name for it. And Docker just allows you to separate that. And Docker works really, really nicely with component level design, I guess. I'm not going to say microservices again because it's just component level design, right? I remember someone at the party was asking me, what talk are you doing on? I was like, oh, fuck, all right, microservices. He's like, oh, COBOL then. I was like, yes, COBOL. And basically, for me, Docker is sort of allowing you to sort of separate these concerns and isolate them. And if you want to learn anything about Docker, go speak to Ben Hall. He's doing some sort of a platform for you to learn how to do Docker, like Prototype, but actually doing stuff rather than just watching videos. So my advice to you is what can I take you off for is try and build your next feature as a service, whatever how small it is. Just try and build it as a service, and you get the question of, what is a microservice? How long, how big it is to define. I don't think lines of code is a good definition for it. I don't have a good definition for it. To me, it's something that I can rewrite within reasonable time. It could be a day or 2, it could be 3 days, 4 days, but whenever I can rewrite it very easily, I can understand it within a few hours. To me, that's a microservice. But I don't think lines of code is a good definition. And now for questions. Okay, so I'll show you some of the dashboards. I was asked to put this up, so sorry about that. Let's have a look.
Question?
Yeah, go for it.
The process you described looked like a saga to me. Are you using this kind of...
N7 plus sagas? Yeah, we've used N7 plus sagas before, but because we moved to Amazon, we just use SNS and SQS with process managers around them. So we've used N7 plus. A lot of the service buses guarantee at least once delivery. It doesn't guarantee delivery in order. So you still have to have some sort of gates to say, okay, I know this must have happened, so that's what I'm going to do. That's why I'm going to check my logic to say, okay, I'm not going to do what I'm supposed to do because I've definitely heard something before. Any further questions?
What was the time span of this journey?
18 months. We initially had to break the website over to speak to APIs, and that's the reason we had to go for it. It was very, very painful, but worth it in the end because it gave us so much freedom, I think. Hang on, I'm just trying to find the dashboards. There you go. So if I set it to other than a few seconds ago to the last 24 hours. Oh. So you see that? If I just do that, it tells you, this tells you, so we've got quite a set of peak here, and this is Grafana, which is the ELK stack, and you can tell right there that these are successful ones and these are attempts. If we do a bad deploy, this is just the cutoff period of the search, but if we do a bad deploy and this thing will immediately go down, and we're like, okay, there's a problem now. We're having a lot more attempts than successes. And the same goes for here. We can be like, okay, see that? That's the number of Sometimes someone's paying. These are the number of options. They saw the number of options, whether it's Apple Pay, which is something we implemented recently, paying by new card, saved card, and so on. And this is the checkout attempts right there. See it? And you've got here, which is no 500s at all, which is actually quite nice. I'm not on call, so I don't really mind, but it's still okay. Over here, we've got a few 500s right there. Well, we've got like 1,000 every 2-3 minutes. These are 1,000 times people are trying to pay, 1,000 orders. It's quite high volume. Same thing for here. These are number of times people are attempting to pay, so looking at the options and so on and so forth.
Is there some sort of risk to over-engineer the kind of simple solution? If you have very simple...
Oh no, you shouldn't. The first rule of distributed systems is don't distribute, right? So if you have like a system that's 3 or 4 services, you don't need, like, when you need to go to scale and it's actually painful to take change, that's when you have to break things apart. But no, it shouldn't be something you should go by default to build. Any further questions? Okay, thank you very much.